Greetings and welcome to this course on the fundamentals of mathematics. My name is James Sellers and I look forward to working with you as your course instructor. As you begin this course together with me, I would like to do two things. First, I want to introduce you to the general topics and themes for this course. And then I want us to begin our mathematical conversation with a review of addition and subtraction of whole numbers. Now, what about this course? In a nutshell, this course will include a number of topics from a traditional high school fundamentals of mathematics course, or what some folks would call a pre-algebra course. The course will treat a number of general topics with a significant focus on arithmetic. Here are some of the key topics that we'll cover together. We're going to talk about adding, subtracting, multiplying, and dividing whole numbers, or what some folks call integers. We'll also add, subtract, multiply, and divide fractions, which sometimes cause trouble for some folks. We'll also talk about decimal numbers and how to put those together with addition, subtraction, multiplication, and division as well. Then we'll talk about things like converting between fractions and decimals and percents. And we'll solve some real-world problems that involve percents, ratios, and proportions. We'll work with whole number exponents, like taking 3 and raising it to the 4th power, for example. And we'll talk about things like square roots, which seem to cause some folks trouble. You know, the square root of 9 equals 3, or the square root of 25 equals 5. We'll also talk a bit about two-dimensional geometry, things like triangles, rectangles, squares, and circles. And then we'll delve into a few other small topics like some elementary number theory, what is a prime number, for example, or when one number divides another number. And then we'll close out our course together with two cousins, if you will, elementary probability and statistics. Now, within each of these general topics, we're going to concentrate on several strands or themes, which include the following. I want us to spend some time mastering the basics. It's very important in mathematics that we understand how to do the basics well. Without knowing the basics well, we'll be in real trouble when we try to handle other kinds of larger problems. I want us to understand the steps involved in different types of mathematical problems. Believe it or not, often it's just about following the steps carefully, one step at a time, in order to finish a mathematical problem. So we're going to spend a lot of time understanding those basic steps. And lastly, we will often think about the answers that we get in a critical fashion. If, for example, we're told we're finding the age of a child and we decide that they're 3,027 years old, then we should probably step back and ask ourselves whether we really did the problem correctly or not. So we'll do some critical thinking along the way as we work through this course. Now, why is such a course so important? Well, bottom line, without a mastery of basic arithmetic skills, the doors are often closed to students who want to learn more about mathematics, whether that's algebra, trigonometry, pre-calculus, or calculus. And once those doors close, lots of different career paths are simply stopped, whether it's careers in technical fields, the medical professions where nurses and doctors have to deal with lots of numbers related to drug dosages and similar kinds of numbers. Even carpentry and plumbing involve a lot of arithmetic. You know, measuring things before they're cut, designing new rooms in a home, and so on. So, all in all, it's extremely important in today's society that each of us has a strong grasp on arithmetic, and that's the main aim of this course. Now, there's another reason that a course like this one is so important. Mathematics is a wonderful way to stay sharp, even when it comes to doing mental arithmetic. So in this course, I'm going to allow lots of us, folks of all ages, to master a topic that may have once proven difficult or elusive for some people. I think you're going to find that you can master this material, and I look forward to helping you do exactly that. Now, what I'd like to do is jump right into doing some mathematics in this first lesson. So let's begin by talking about addition and subtraction of whole numbers, or integers. Well, before we actually get into that discussion, we should definitely talk about whole numbers in general and about what the digits mean in a whole number. Let's look at the following example. Take a number like 728. What exactly does that number represent? Well, in the number system in which we work, which some folks call the base 10 system, 728 means that you have 7 hundreds, and you have 2 tens, and you have 8 ones. Each of these digits is in a certain place, and they mean something depending on their place. The rightmost digit in a whole number always represents the number of ones in that number. And then from there, we're looking at the tens digit, and then the hundreds digit, and so on as we work from right to left. Now, as we work with larger numbers in the future, I'll try to talk about what those later digits, the digits farther to the left, actually represent. Now, if you've ever experienced confusion over these digits, let me try to give you a different way to think of a number like 728. I would encourage you to think of 728 in terms of dollars. What would be the most efficient way to have a stack of money that amounted to $728, especially if our system only allowed for ones, tens, $100 bills, $1,000 bills, and so on? Well, it would definitely not be to carry 728 $1 bills in my pocket. That would not be efficient at all. I'd have this large wad of money in my pocket. Not only would it be lots of stuff to carry, but if you had to buy some groceries at a store for, say, $89, then counting out $89 just using $1 bills would be a real pain. The most efficient way to carry $728 is to have 7 $100 bills and 2 $10 bills along with 8 $1 bills. You would then only have 17 different pieces of paper in your pocket or in your wallet, and that's not a bad thing. Now, when we think about adding or subtracting whole numbers in today's lesson, it will help us to think of the numbers as such a collection of digits, where each digit represents a different power of 10, like the ones or the tens or the hundreds and so on. Because we actually complete the process of adding or subtracting two whole numbers one digit at a time, starting with the rightmost digit, that's the digit in the ones location, and then working our way to the left. Okay, enough of this philosophical talk. Let's get to an example. We need to do mathematics. We need to practice mathematics as much as we can. And so I'd like to get to some examples. Let's do a brief one right now. Let's add 42 and 37. Now, as we walk through these kinds of examples, I'm going to try to give you several pointers on how to make these problems go smoothly. In this case, the first pointer is that we should write the numbers one above the other as you prepare to complete the problem. In other words, I want to write the 42 above the 37. Now, when I do this, we need to line up the corresponding digits very, very carefully. There's a certain neatness about mathematics that's very, very important, especially at this arithmetic level. So we're going to line up the ones digits, and we're going to line up the tens digits. And every time you and I add two whole numbers, we need to line up these corresponding digits in this way. So we need to make sure the ones digits are one above the other, and the tens digits are above the other as well. And now we just add by the columns. Thanks to writing so neatly, this work becomes very straightforward. So we're going to take the 2 plus 7, and we're going to get 9, and we're going to write a 9 below the 7 in our answer section. Then we're going to move over to the next column. We're going to take 4 plus 3. We know that equals 7. And so we're going to write a 7 below the 3. And that gives us the final answer. The final answer is 79. Now, let me make one comment here about what you and I just did. It's going to be very important throughout this course that you know the basic arithmetic facts really well. For example, I just said pretty quickly that 2 plus 7 equals 9, and that 4 plus 3 equals 7. For many of you, those facts are well known. For some, that may not be true. So it's very, very important that you know these kinds of things for addition, subtraction, multiplication, and division. If you need, you might want to purchase some flashcards or make some flashcards of your own and practice with these single-digit facts, things like 2 plus 7 equals 9. This will really help you in the long run. And let me tell you a quick story from my own past about flashcards. When I was a young boy, which was a long time ago, my grandmother used to test my basic math facts with flashcards. Once I'd worked on a certain set for a while on my own, she would require me to say the answer as quickly as she showed me the card. If I hesitated in the least, she put that card back in the to-do pile so that I could answer it again. I would encourage you to come up with a similar speed for yourself. Once you've worked on a set of facts for a while and done the memorization, don't just be satisfied with knowing the facts with some hesitation. Know them like the back of your hand, and that will help you tremendously as you work through a course like this. Now, you may be wondering at this point, why don't we just use a calculator? That's a great question, and I'm glad you asked it. Let me answer it by first sharing my philosophy on calculators. While I believe calculators can be useful, and I use one myself from time to time, I fear that students are sometimes allowed to rely on them too much. In fact, I would encourage each of you to learn the material in this course without the use of a calculator. These skills that you're going to develop are extremely important, and they're within your reach without the aid of a machine. So I suggest we put those away. Every once in a while we'll take them out, but only on rare occasion. Otherwise, we're going to use our brains and we're going to learn this material together. Now, there's another reason to master this material without a calculator. From time to time, it's very important to know whether you've completed a mathematical calculation correctly. And the ability to estimate your answers or to do some of the work in your head allows one to know whether a mistake has been made, especially if you rely on a calculator and you hit a button incorrectly. Without the ability to do some of the work mentally, you may not be aware that your answers aren't even in the right ballpark. So let's rely on our brains and let's make sure that we work on the problems together, at least in terms of estimations, to make sure we're getting the right answers. Now, before we move to another example, let's think a bit about the example that we just completed from the mindset of the dollar bill analogy. Basically, we could have thought of that problem as having $42 and then also getting $37 more and trying to figure out how much we had in total. So if we had that efficient system going, we would have started with 4 $10 bills and 2 $1 bills. Then we would have added in 3 more $10 bills and 7 more $1 bills. That would have given us 7 $10 bills and 9 $1 bills for a total of $79. And 79 was our final answer. So that tells us, in a nice analogy with this money, that we would have had the correct answer. Now, let's look at a slightly more complicated example. It's only going to be two two-digit numbers again, but there's a very interesting twist that occurs with this example. Here it is. Let's add 29 and 53. Okay, so what's the first thing we need to do? We need to be careful about how we write the numbers. We're going to write them vertically again, one number above the other, and we're going to make sure that we line up those corresponding digits. So we're going to write the 29 on top, we're going to write the 53 on the bottom, and we're going to make sure that those ones digits, the 9 and the 3, line up. And then, of course, we need to make sure the 2 and the 5, which are in the tens digits, also line up. So once we've lined everything up, it turns out that the problem is pretty straightforward to do. We're going to first add the ones digits. So we're going to always start, when we're adding like this, with the rightmost column. When we do that, we're adding 9 and 3. Now, that gives us 12. And now we have an interesting issue. Unfortunately, we can't fit 12 under that 3 because it's a two-digit number. It's too long. So what do? Do we just stop and give up? No, of course not. We know how to handle this. I'll show you how. From a mechanical perspective, we always take the ones digit from that 12, that would be the 2. We're going to write that under the 3, and then we're going to carry the 1 from that 12 to the next column to the left. It's this carrying which is going to prove very helpful and important when we add up these multi-digit numbers. Now, I like to write that 1 as a little tiny 1 just up above that 2 in the number 29 to remind me that I have another 10 to add in. That 10 is coming from the 12. Then I add that 1 along with the 2 from the 29 and the 5 from the 53. And when I add the 1, the 2, and the 5, that's going to give me 8. I'm going to write that 8 under the 5 in 53. And that gives me my final answer. My final answer is 82. Now, why does that work? Well, if you go back to that efficiency dollar idea that I was giving you earlier, we would have started with 2 10s and 9 1s. That's from the 29. And then we would have thrown in 5 more 10s and 3 more 1s. Now, when you count the $1 bills that you now have in your hands, you would actually have 12 $1 bills. Remember, we had a 12 before, a few moments ago. But carrying 12 $1 bills in my wallet isn't very efficient. Instead, I could have exchanged 10 of those $1 bills for one $10 bill. And then I would have one $10 bill and 2 $1 bills, which still amounts to $12. But now instead of having 12 ones, I would only have 3 bills, one $10 bill and 2 $1 bills. So I have that 2 that goes into the ones digit, and I have this new 1 that goes into the tens digit, and that's coming from this new $10 bill that came out of the picture. Now, that's where the extra little 1 comes from. It comes from that $10 bill that I got from exchanging it for 10 $1 bills. It's a great analogy. And now I end up with 8 $10 bills. The original 2 $10 bills that I had, plus the 5 $10 bills from the problem, and this new one $10 bill that came in when I exchanged some of those ones for a 10. That gives me 8 $10 bills and 2 $1 bills, $82. That was my final answer. Now, I'd like to suggest that you try one of these for yourself now. I'll give you the problem, and then a little icon will come up on your screen. It'll count down to 0. While it's counting down, pause the lesson, grab a pencil and some paper, and see if you can do the addition. When you think you have the answer, start the video again and see if you got it right. Here's the problem I'm going to give you. Let's add 1,758 or 1,758 and 4,632. Okay, we're always going to start by writing our numbers vertically, lining up the corresponding digits. Very, very important. The ones digits are lined up, then the tens digits get lined up, the hundreds digits get lined up, and finally the thousands digits get lined up. You see how the 1 and 4 are in what's called the thousands digit or the thousands position? Once you have all of those lined up, where do you start? Always on the right-hand side, working our way to the left. So let's start on that right-hand side. We have 8 plus 2, which is 10. So we write a 0 under the 2 and carry that 1 over above the 5 that's in the tens digit. Write it as a little tiny 1 if you want to remind you that you've just inserted that. Now you have to add the 1, the 5, and the 3 that are in that column. And when you add 1, 5, and 3, you're going to get 9. We write that 9 under the 3. Now notice we only got 9 here, so we didn't get a 2-digit number, which means there's no carrying. So we just move over to the left, one more column. That now puts us in the hundreds digits, and we see we need to add a 7 with a 6. 7 plus 6 is 13, and so I'm going to write a 3 under my 6, and I'm going to carry a 1 over to the thousands digit location. And that 1 is just going to go above the 1 that's already there in the thousands position. When we finish this problem, we're just going to add that last column. We're going to add the 1 that we just wrote in, the 1 that was already there, and the 4 that was already there. And when we add those numbers in that column, we get 6. We put that in the answer location, and that gives us our final answer. Reading left to right, it's 6,390. Now, as we close out this lesson, I'd like to transition to doing some subtraction problems with whole numbers as well. We've done some addition problems, and now it's important that we do some subtraction. One thing to remember is that subtraction is the exact opposite operation to addition. So in some sense, subtraction undoes whatever we do with addition. It's sort of like this. Think about tying your shoe as doing an addition problem. If you wanted to undo that, you would untie the same shoe, and when you do that, you've done subtraction. So addition and subtraction are sort of opposites of one another. Some people like to say that they are inverse operations of one another. And so now it's important that we be able to do subtraction as much as we can do addition. So let's do a few examples with subtraction just to make sure we understand the steps there. As a first example, let's just do something small. Let's subtract 13 from 85. Now, I asked this question or posed this example very carefully because one of the things that gets confusing is to know whether I'm doing 13 minus 85 or 85 minus 13 in that problem. Well, I asked us to subtract 13 from 85. And that means that we're actually trying to do 85 minus 13. So that's the problem at hand, 85 minus 13. Now, then once we figured out the problem, it turns out that just like with addition, the first thing we want to do is to write the problem vertically. So we're going to write these two numbers, 85 on top minus the 13 on the bottom. And just as with addition, it is extremely important that we line up those corresponding digits. So the 5 needs to be above the 3, and the 8 needs to be above the 1. That's because we're lining up the 1's digits together, and we're lining up the 10's digits together. Well, just like with the addition, we're going to start with that 1's digit, the far right column, and we're going to work our way to the left. Addition and subtraction work the same way in that sense. Starting on the right column, working our way to the left. Now, we start with that 1's digit column. That's the 5 minus the 3, and 5 minus 3 is 2. So we're going to write a 2 in the answer section underneath our 3. Now we work our way over one column and we see 8 minus 1, which is 7. And so we're going to write a 7 under the 1. And we're done. We just read off the answer. It's 72. That's it. Isn't it neat to see how the steps here involved in subtraction have a lot of things in common with the steps for addition? Unfortunately, they're not identical. Obviously, addition and subtraction are different things, but the differences between the two can be seen very quickly. And so what I'd like to do is look at another example now. It gets a little more complicated, but you'll see that it's very straightforward to do. So here's the example. I want us to compute 81 minus 45. Well, we start the problem just as we've started every other problem in this lesson by writing the problem vertically and lining up those corresponding digits. I can't say enough about how being careful about what you write and being neat about it can be very, very helpful with your mathematics. So I'm going to write my 81 minus 45, and I'm going to line up those corresponding digits. I now start with the rightmost column. Here, that's the 1's digits, and I'm going to subtract. Well, unfortunately, 1 is smaller than 5. I picked this example carefully so that we could run into this issue, if you will. The 1 is smaller than 5. So what do? I can't take 5 away from 1. Well, think with me again about those dollars, because that's very, very helpful here. If having $81 can be thought of as having 8 $10 bills and one $1 bill, then we can also think about someone asking for $45 or for us to need to give someone $45. Well, then we would have a problem because we wouldn't be able to give them all of those $45 with the right change, if you will, because we only have one $1 bill. So it's going to be helpful to think about another conversion with our money. So think of it in the following way. We have our $81. We take one of our $10 bills, and now we exchange it for 10 $1 bills. Now, if we started with 8 $10 bills and one $1 bill, and we take that 110 and exchange it in the way I just described, it means then that you would end up with 7 $10 bills and 11 $1 bills. Now, if you think about it, it's the same amount of money, right? It's still $81. But now, by having exchanged that one $10 bill, we now can give someone $45 that they wanted. And that's exactly what we're going to do in the subtraction problem that we started with. This is now called borrowing. Basically, we scratch out the 8, we turn it into a 7, and then we change the 1 that was in the ones digits to a little 11. It's exactly what we did with the money I just described. And now that we've changed that 1 to an 11, we can actually do the subtraction column by column. And that borrowing is going to help us tremendously. So now I look at my ones digit and I see 11 minus 5, and that equals 6. And so I write a 6 under the 5. And now I move over one digit and I see 7 minus 4. Remember, it's not 8 minus 4 any longer. It's 7 minus 4. That's equal to 3. And so I write a 3 in the answer section under the 4. Notice that it's extremely important to keep everything lined up here. Everything works out very well when you do that. And now I have my final answer. It's sitting in the answer section. It's simply 36. Now, by the way, did you notice how borrowing is like the opposite of carrying from addition? It really is. But it shouldn't be too confusing if you keep the dollar exchanging idea in mind. We're going to be borrowing with subtraction problems, and we're going to be carrying with addition problems. With practice, this will all work out really, really well. Notice again how important it is to know those basic facts, like 11 minus 5 equals 6. Without having those put to memory, these bigger problems are going to become very difficult. So make sure you're doing that practice with the smaller digits so that you can answer those pieces quickly in order to do the larger problems. Now, I'd like to look at one last example of subtracting whole numbers as we walk through this lesson. Here's the problem. Let's calculate 842 minus 791. Let me let you try to finish this one yourself. Pause the video, work through the problem, and then come back and let's see if you have the right answer. Okay, how do we start? We start by writing the numbers vertically and we line up those digits. And then we start subtracting from the right, working our way to the left. Well, the first thing I see is a 2 minus a 1, which is 1. That was easy. And there's no borrowing required there because the 2 was larger than the 1. So I just write a 1 under the 1 in 791, and I have that 1 now in the answer section. I now move my way over one column, and now I see that I want 4 minus 9. Uh-oh, 4 is not big enough to handle subtraction by 9, so now we do have to borrow in this tens column. That 4 is too small. It would be like having 4 $10 bills, but needing to give someone 9 $10 bills. So we're going to change the 8 to a 7 and change the 4 to a 14. And then we have 14 minus 9 equals 5. So we write a 5 under the 9 in the answer section. And lastly, we have 7 minus 7 in the hundreds column. And that would be like writing a 0 under the 7 in 791. But of course, this is unnecessary. Putting a 0 in front of a number doesn't change the value. And so we know that something like 051 is the same as just 51. And so my final answer here is just 51. Now, as we close today, I hope that this review of adding and subtracting whole numbers has been helpful. I encourage you to practice with the problems in the workbook that accompanies this course and to think hard about the steps of each process. Notice that these steps occur the same way every time. And unfortunately, mathematics can often be mysterious to some people because they can't get the steps of the process down. Be sure to practice those steps the same way over and over again until this feels very, very natural. Now, what's the best way to use the course workbook with the videos? That's a great question as we close this lesson. I would suggest that you briefly read over the material in the workbook before you view the lesson's video lecture. I would then go back to the workbook, reread that material a second time, and then work through the exercises for the lesson. The course workbook is a great place to start. But what if you want even more practice? I mean, I can only give you so many problems and exercises in this workbook. Well, if you're taking a pre-algebra course in school, your class text will work just fine. If not, there are lots of pre-algebra or fundamentals of mathematics texts on the market. I've listed a few of them in the course bibliography, and I would encourage you to supplement the work in this course with such a text. You'll be amazed at how practice can really help you nail down the concepts in this course. Next time we're going to talk about multiplication and division of whole numbers, which, like addition and subtraction, are opposite operations of one another. I look forward to talking with you then.